Good morning and happy Tuesday. And good morning. Hey, 715209. How are you? Yeah, doing pretty good. Doing pretty good. All right. So we're going to get into some tessellation stuff today. Now, we're not going to tessellate the islands. I know. That would be a lot of fun, actually, but I got to keep my eye on the prize here. We're going to use a tessellation uh, lib that's already existing. We're going to continue to tessellate the triangles. Now, one of the goals here is that we've been creating a bunch of triangles, right? From the A sprite example here. This is our example from yesterday, and we could see that it's taking these inputs, it's culling off the tail there, it's removing the yellow unneeded triangles. I did a little test last night with a random big island, and that just by removing the extra segments there, it lowers the number of triangles uh, from like 3,000 to 1,000 in one example. So overall, pretty good because those wouldn't actually be needed for rendering the exact same thing. They didn't help. So now we're going to be working on something very similar to this. I'd like to come up with a small example, a little test case. Hey Zenocron, how's it going? How are ya? So we're going to work on another little test case here. Gonna grab this, copy. I'm going to paste that up here somewhere. Look, a grid without having to worry too much about. Oops, there we go. I'm going to do a little fill here. Pretty good. Hey, Belgian. How's it going? Belgianal. Wait, it's an I, isn't it? Damn, that monitor. Belgianal. I think that's an L, isn't it? Well, we're going to be creating some sand here. I'm going to create just some dinky little island, right? So I want a simple test case where we could have something else inside of it. So I think this is going to be important. Let's say that inside of this section we actually have a grassy section. That's not very green. Well, it is green, but it's not very bright. Oh, wow. So we do something like this. Or if we, a little further here, we can get another one. So I want to create some little test cases, kind of like this, because what's going to end up happening is there's going to be different heights to the island sections for this. Could anyone ELI 5 tessellation? I mean, it's pretty much just circles. Let's see, do they reference some algorithms in here? So with contours, Veroni tilings, these are cool. But if you're trying to tessellate a space into triangles, you're probably going to be looking for something like more like a Delaunay. I keep saying that wrong, but you're going to be looking for something like this. And then there's modifications of this where you can have constraints on the types of triangles that are generated. And that would be a constrained Delaunay triangulation. And if you look in here, it's really just circles. You're trying to find a circle that matches 3 points. Yes, or more in some cases, but more is usually pretty rare. All right. Oh, I have a Firefox update. Now let's come back to the code while that updates. Oh, here's the example. So in this case, there were 2,980. I don't have enough lines to go back. Let's see if we do that one more time. Is it gonna show? So this is the one where we didn't remove the extra vertices, and in this one we did. That's technically it's a different random set of numbers. So yeah, it produces much smaller, well, larger triangles, smaller number of verts, just by removing a couple of things, which is really nice. I mean, we could go one step further from that and start to remove touching points, which we might do in the future. Because there's a difference between something being visually correct and fun to play, or appearing to be visually correct and fun to play. Because we could probably reduce that down by half again. All right. So Tessellate Island. We are going to test that. Two L's. All right. Island polygons. Now this is something that where we were already testing simplify. So I'm going to just pull some of these shapes out of here. That's all that really need to test this. Well, we'll need something a little bit more complicated, but this will get us started. What I would like to do is have the outer sand island, something like that, and then have inner grass with a bunch of points in here. I'm just going to toss them in there for a moment. And we could just make these really big. So here we'll have 1 point. We're going to do maybe just a square here for our outer island. I mean, we could do 5 points. We could do 6 points. So if we come back to it's here, let's just create something simple. So at 1, 1, what was that? That was 6. 2. All right, so we'll do something like that for the outer ones, and then for the inner ones, we'll do something like that. So if this is green, now if that's the pencil tool, it has a shortcut of B on it, which I don't get. No. Oh, I keep doing Shift B. That's why it always fails. All right, so we have 0 there, 0 here, 1, etc. So at 1, 1, 3, 6. Okay. So we have something at 1, 1, 1, 6, 6, 6, and 6, 1. And these are just going to be 3, 3, 3, 4, 4, 3, and 4, 4. Okay. We need a vector shape. I don't think having the double vectors actually helps us with anything. It just happens to be that's what we end up with. There we have sand and grass. I think this is more along the lines of the format that we're expecting. And these are kind of akin to the heights. So this would be like height 0, or rather height 1. And it wants these as shapes too. Fine. Because there might be multiple pieces of grass, multiple sand shapes. Just one more layer. We really got to rethink that. Alright, because all this is going to do is take it down into just points. We end up with points. Just fine. This might actually change later. And then we're going to get triangles here, in which case I think we should basically return just a vector of triangles. The difficult thing here is that we want to get the triangles, and then we also want to color them. Basically figure out, okay, what zone of noise are you? Well, we had been passing that through using the island point. We're not doing that anymore. And I think we're just going to look at the center of the triangle and color it based on the center of the triangle. What do you think about that? Interesting. Well, we could create just a triangle here. Because we have points, we have all these other elements. And we just create triangle. Oh, that's right, we cannot name those. There we go. Uh-oh. A man walks into a zoo. The only animal in the entire zoo is a dog. the Shih Tzu. Well played. Well played, sir. What about the zoo? It's not very good either.
On your feet, everybody.
Okay. Vector of triangles. Oh, Belgian. What do you get when you cross a Shih Tzu and a Bulldog? That's a good one. That's a good one. I mean, even the other way is like, yeah. Because you could tell that in like the clean way. Because there's so many ways that could go bad, right? What is the difference between a dirty bus stop and a lobster with breast implants? One is a crusty bus station and the other is a busty crustacean. Oh dear, wow. Let's see. No, I just need to check to see. Did I already have jokes recorded for Belgian? I don't think I did. Maybe there's somewhere else. Oh, no, there is one. Now, if you don't mind, I'm actually I like. See, I think people are so used to seeing like seeing that. I think that they will naturally come to the answer being uh the BS there. But if you go with the BZ, I think it catches people off guard. All right. Anyhow, back to the code. Um, so we're going to do this. Okay, mark it. Oh no. Oh, it was in the Dumb and Dumber movie. Oh, that's great. That's funny. paste it as triangle, and then we will keep that. Oh, we could probably use the combinator on this now. What does this return? It's a Rust will tell us. Oh, it's a faces iterator. We don't need more than one iterator. Okay, so it's a vertex handle. It's a array of 3 of those. Got it. So we want to create a from for our triangle. There's triangle, here we go. Can we do this? You not just say from this 3 item element, we want to create this from. Oh, and with a proper from, pull from that for that. Man, I am so dense this morning. That needs brackets around it. Okay, so we do need the lifetime. Let's back up a little bit. Let's bring those little bits I deleted back. Okay. From that, for that, it's going to complain about the deleted lifetimes. Triangle in the scope. Oh, it's a triangle. Hey, Billy. How you doing? Hey, good morning. John DeSan Donato. Good morning. John DeSan Donato. That's a cool handle. Okay, that should probably work as long as it... Oh, interesting. The vertex handle. Yeah, that should be a point. Game type's point. Vertex handle. Do we have to deref that? Oh, yeah. And good morning to you, too. It is looking to be a clear, cool day. All right. So we have our triangulation here. We're going to go back to spade. Vertex handle. Odd. Okay. Let's go back up to the Delaney one. We had this working before. Oh, we have to deref it. Oh, okay. I'm looking for the mosquitoes going away. I agree. Oh, that's right. We got rid of using points there. Why did that happen? We could just do this. Get rid of the new. We're not using that. Except for there. We're using it right there. All right. I like computational geometry. What time of year has the best weather? This feels like a joke. I don't know. What? I guess we could have taken the face too. Could have done that from a face handle. Regardless. Okay, it looks like we have this correct now. Now this way we are going to show these triangles. Let's implement display for them. B.0, B.1, C.0. Oh, and we want the height. Yeah. Oh, what time of the year is the best weather? Yeah, it's the kind of like the spring and the autumn, like when the bugs are all gone. It's not like late enough for in the spring for the bugs to be up and about. Let's add some more spacing. It's saying that there's an error there, but it's not saying what it is. All right, we'll destructure self into that. Oh, of course. That's going to be a 0. All right. Now we did display there. We could have done this debug. They're basically the same thing. So if we do debug instead, then we can debug print them out, which is all we really wanted. Anything that's not more than 25C is good? Yeah. Alright, now we're going to take and run this test to see what sort of tessellations we're ending up with. And where's the water? There we go. We're gonna eyeball this. Are these correct? We got. Well, we're gonna go from 6.6 to 4.4. That's this one here to 4.4. Oh, I should use a line for that. Like seriously. If you don't use A-Sprite, it is a really neat little just. It's like MS Paint, but simpler. All right, 6.6, 4.4, and 4.3. Oh, yeah, I got that wrong. Okay, so it's going to be here to here and then up to there. That's a good one. Okay. The next one's 1161. So here, 61. Yep, that's good. To 33. That makes sense. Guessing we're gonna see that. Yeah, 66 to 43 to 61. Oh, 66. That's this one way out here. To 43. Why is it going to 43? So here, hold on. Did I get those backwards? All right, so 66. Oh, I did get those backwards. So 66 should be out here first, going to 44 to 43. All right, and then that comes back. Ah, I see. All right, then 11 to 61. 2 pixels. There we go. 11 to 61. To 33. Oh, that's so weird. Okay. So it's gonna be like that. Oh, I don't want that filled in though. Oh, it looks like they don't have an option for that. Oh, whatever. So we're just debugging a little bit. There to there to there. And the third row is 66 to 43, which is there. Okay, that line's already there. To 61. So this one's coming out this way. Going down to 66 again. I mean, it looks pretty good so far. 11 to 33. 11 to 33. Yep, we already have that line there. To 16. It's out this way. 66 and 16. That's coming across to 34 here. One 6 to 3-3. Okay. So 3-4. That one basically closes off that one. 3-3 to 3-4. 3-3 to 3-4. No, 3-3 to 4-3 to 3-4. So that's actually this one here. Yeah, this looks like a pretty decent triangulation of this. Three to 6-1, 3-3. Are there too many triangles in here? Because how many should there be? So this looks like a complete tessellation here. How many do we have? 1, 2, 3, 4. So 4 on the outside. Here, let's fill them in as we count them basically. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Yep, there's 10. Great. And that's a pretty decent tessellation of that. Let's see, what do I have? Wanted that a different way? No. And in fact, the pathfinding is going to combine some of these. So the pathfinding, when we do this on the server side, we're going to take it one step further, because the client needs the tessellations, needs the triangles for display. The server side is going to be taking these pieces and like this two set of triangles here, it'll combine those like that. So on the server side, we'll end up with just 4 big, what are those, trapezoids on the outside, and a square in the middle. So the pathing should be really cheap. Okay. Oh, you know what? Let's. There we go. Opening tabs again. Okay. I verified those are correct. I guess that's actual here. We want to fill in the expected. All right, now we actually need a whole bunch of triangles here. Comma, B. There we go. Now we can compare them. Assert that these are equal. Expected and actual. One more test. We need partial equal and default. What was the other one? Default. Oh, and clone. That's an odd error. Conflicting implementation of partial equal. Oh, it's on there twice. I guess it's Half-Life was awesome. It really was. Oh, it's expecting it to be a vector. There, now it's a vector. Okay. Just make sure that is captured. Because that's a good tessellation. That's nice. Good. Now that we know that we have a valid output here, now we're going to go through, create a very small island from scratch, using a specific set of noise. Oh, we probably shouldn't do that, should we? Okay. So to go through basically the whole set of, the whole suite here, so this one, no, we don't. This one here is just checking that for 100 items that certain base criteria are met. Like there's a certain amount of water, etc. Island vector generation. Okay. We're going to be working on this test. This is the one we've been building up to. Set a marker. So here we have tessellate island, and then we'll have our triangles down here at the bottom. Now this island size is 5, and we'll print out the island. And I don't think we need all of these debug pieces. Not yet. It's so much easier doing these things with tests as opposed to just trial and error and inside of Godot. That was more than I was expecting. I was expecting some island with like a size of 5. Well, there's our island if you haven't seen one before. So in this case, you can see that the island is contoured around the edges. So the ocean has weathered it a bit. It's got different zones in here. Here we have zone 1, zone 2. It also seems to have some sort of water feature coming through it. It's got a 0 going through the middle. And it's got zone 3 with little tiny blips out on the right there. I like this little inlet on the left. This looks cool. Alright, and it triangulated that mess. Oh, not bad, okay. I was hoping for a smaller triangle. Ah, it's using island size here. Let's try 11. I know Clippy's not gonna like that. But... oh, it can't do it. Alright, where else do we use island size in here? We don't, only one place. Okay, that's easy then. Island size shall be 13. I mean, can we get away with 9? It might be too small because of the waters around the edges. I keep fighting with this actually. There's 3 waters around the entire outside. I would rather have the water added later and this just be the islands. So I'm going to remove that. Alright, we'll deal with that mess later. Yeah, that should be okay, now that I think about it a bit more. The old code was relying upon there being this border of water on the outside so that we had trigger zones, but I think we're going to have to set that up a little bit different. Oh, this is the client code. We don't have to fix that up yet. Alright, hopefully we have a smaller island. There's our island. Oh, look at that tessellation. Looks great. We're going to try to get the heights in there. So we're going to need the noise from the very beginning back again. So we can sample the center of these triangles in that noise and set the height to those values. So in this case it'll be 1, and in this case it'll be 1. No, we need the same noise back. We need this noise. Ooh, and what do we do with the noise along the edges? Hey, Peyton Rules, how's it going? And welcome. Welcome, Raiders. Sorry, I was focused on the code. The code had my full attention. How was your stream? Actually, let's. Is Capitan up? I want to see some bad input get. Okay. Fella99, how's it going? Oh, you got rid of a nasty bug. Oh, that's awesome. What's up, Yaza? Fella99, why are you dropping Yaza in here? Alright. Well, let's get back to the code. I think it's a new streamer. Apparently, Yaza's either got people spamming or doing something weird. Alright. Well, let's get on with it. Hey, Krasink, I'm doing well today. We got some tessellation going. See, look, this itty bitty island got tessellated correctly. Now we're gonna add the heights to it. We got some more unit tests in there. It's awesome. I don't know how I'm going to do this with the outside. I want to listen to something real quick.
And here I can zoom out.
Oh, there's the other one.
Yeah, I'm glad you like it. Made just for you. For all
All right.
got this.
Black spires in the city sky, they shimmer and shine tonight. Act wise and a
All right. Let's keep going.
million flashing lights, and I can wish myself away. Change the parts that bleed decay. I'm just a number writing solo in the cold.
So how are we gonna get this so that the noise of the edges is actually taken into account? Because depending on the radius from the center, we would use one set of noise, and the radius on the outside a second set of noise.
Tech dreams of organic toys that are running out on the edge. Soft screams of the rocker boys echoing through my
All
head.
right.
Hounds and demons mechanized. Biotech behind our eyes. And I'm just a number riding solo in the cold. Electric embers will ignite.
Yeah, we're gonna have to basically create these two sets of noise to be able to sample it. Okay, let's do that. Ooh, oh, a bad joke. What did the farmer say after getting a headache from people stealing his wheat migrants? You got migrants. Oh. All right, that was a good one. That was a good one. I got to work on the delivery. I didn't. I read through. Now, do you want it with the without the punctuation there, or do you want punctuation there? Because migraine, I mean, I get migraines occasionally, and they they change the way I speak. Yeah, warning was yesterday. Took some meds, but it's questionable. Yeah, for me, the best I ever got was I do get the ocular kind of precursors as well, and for me, like just loading up on ibuprofen, um, and then taking a nap. That's pretty much the best for me. That and there was this other thing. I watched this old study about actually I don't know how old it was, but they were able to put kind of brainwave monitor on people that very regularly got migraines, right? And they might not last very long, whatever. They found this set of people and they basically taught these people what their brainwaves looked like when the migraine was coming on. So they showed the people these brainwaves, and in real time, as their migraines were coming on, their brainwaves changed subtly, and they asked the people to change their brainwaves, right? So they could actually see their brainwaves and on the monitor and could try to do things to change it. And after seeing that, um, I thought about that a lot, and I've had fewer migraines because of that. Just like maybe you can actually think them away. You can change the way your brain waves are. Basically the whatever your brain is doing. And I haven't had as bad migraines since. Kind of like the I don't know. It feels like willing them away, but I don't know how to describe it really. Because when I get just the sense of the ocular starting, sometimes, like within the first 5 or 6 seconds, if I think about it in just the right way, they go away. And I have no sort of medical sort of foundation for that at all. But after watching that video and seeing these people able to more or less think their migraines away, I tried that. And I don't know, I think everybody's different, so if it works, cool. If it doesn't, I'm sorry. Yeah, migraines are awful. Awful, awful. All right, I think we should extract the noise generation out. Function, generate noise. Do we need the size for this? We're just going to be creating these. I don't think we need size. No, we're just going to be returning these 2 FBMs. Oh, look at that. Yeah, I sent Yaza a message on his stream saying that people were doing this. Seems to be somebody farming for followers. I don't know. It sucks. You also suffer migraines every few months since childhood. Can't figure out the trigger. For me, it was it's a lot of light. Like if I get flashed, like specific sorts of combination of lights. All right. So we'll do that. That'll be the first one. This is the land noise. And the second one, the edge. Let's call it the shore. There we go. But what are the types there? Is it just FBM? Okay, so it is just noise FBM. Perfect. Want to be famous? Maybe you paid for the wannabe famous service. Alright, so we'll have island noise, shore noise. Ooh, we don't want to... I guess we could just pass those in, couldn't we? It's probably better to pass those in. I don't think we need seed in the mask anywhere else in there. Yeah. World Gen, yes, yes, yes. All right, so we are going to just pass those in instead. Yeah, what is that icon? What is OWL Access Pass 2018? All right, now in this case, we're going to be looking for island. That's probably the noise function that we need. Oh, Overwatch League. Oh, very cool. Alright, so we can get rid of this one. Now we know where that's going. Now we take the noise there. Oh, we cannot allow this year to end. That would be admitting that 2021. Too soon. Too soon. Yeah, I hope everybody's staying safe out there. Alright. Oh, that sucks. I mean, where are Twitch admins? Like that's it. That's an interesting thing. What are Twitch admins? All right. So generate island grid. Where do we call this? Oh, 4 places. Wow. So we'll have the island, and then we'll have the shore. Alright, so we have that and that. Mismatched types. Oh, island mask. There we go. Oh, Twitch and Discord button going. That sounds cool. With a Rust Wasm front end. Have you seen the Twitch chat? That one seems to do IRC really well. In terms of the web request one, the webhooks, it doesn't do that. But I couldn't say. Alright, so we'll pass in the island and the shore there. And I think technically we want to pass it by reference. Ooh, is that going to mess up the gets? Doesn't look like it. TMI library. All right. Generate island grid. There we go. Oh, those need to be borrowed. Where are we here? Persist island data. I don't think this function is even going to be used anymore. Hey, hey, Brooke Zerger. Good morning and welcome. How was your stream? All right. So we're working on island generation for the game. Okay, we've extracted out the noise, so now we should be able to also use the same noise for island and shore with Tessellate Island. Oh, if you're able to use Rocket and Serenity, that would be a dream. Have you been using Rocket? How is it? And I've not heard of Serenity. Let's take a look. Oh, Discord API. Oh, nice. Gotcha. Gotcha. Yeah, Capitan is also using Twitch chat. All right, so we were down here. Tessellate triangles. So we're going to color them now. We're generating the island grid. We have the noise from before. Now that we have the triangles, we need to figure out where in those, in the noise, those triangles are. So we can say, oh, this triangle represents this height. And the secure guards. Oh, I have not heard of that. Created a wrapper around Twitch chat, so you could drop it into other projects easily. Oh, that's cool. Oh, benchmarks are full of smoke anyways. So, especially stuff like that. I would say, you know, when you're looking at benchmarks like that, you're looking for big movements, like big differences in things. Like, look at Actix compared to Rails, or PHP, or, you know, some other C++ lib. They're going to be in the same order of magnitude. They're going to be like C++ and Actix are within the same order of magnitude, not Rails. Request guards. That's cool. Gotcha. Definitely not Rails. Yes, yes. So we'll color triangles, or I don't know, give height to triangles. Like, we could pass that into Tessellate as it's creating them. We create the triangle face, and then we also look up the height. I like that. I like keeping these simple though, being able to wire them together. We'll give it immutable triangles, the island, and then the shore. It's going to need that. Oh, do I have any dot files up? We've got loads of dot files. So my dot files and Xenocron's dot files are the pretty ones. And we've also got commands. And if you're looking to chat about game dev or Rust offline, pop into Discord, etc. Alright, set triangle heights. What are triangles here? Just a vector of triangle. Got it. So many tests now. Actually, could we pass the by reference in and do that? What am I missing? Oh, maybe a variable name. Alright, now something else that was in the noise here. So we will calculate the center of all the triangles, well, each one individually, and look its center point value in the noise. Round that. Are we flooring it? What are we doing up here? Alright, what is world mask? Oh, we're getting the absolute value and rounding it. I think these value, this here, should actually be extracted. Just so that we are doing the same thing in both places and we don't end up with some big comment up here that nobody will ever see that says, please update the other function too. All right, so let's go ahead and extract these. It's going to take the noise, so we'll have the island noise here. Oh, you know what? I need to change my phone real quick. So the X and the Y are both going to be F64s here, not 46s as I keep trying to type. And the result will be a U8. Hey Pro Theory 8, good morning. You think you're going to contribute to a project written in Rust soon? Oh, that's great. Alright, that should be it for this. And this is Island. Oh, needs to know the lands. That's a U size. Alright, that's better. Now we can actually use that down here. And whatever X and Y were. X, Y. There we go. I think we need as F64 on those. Or probably ints or something else up here. U size, yeah. Alright, one more for the other kind that we have here for the shore. The shore is a little different. Is it? Absolute round. Oh, with the, yeah, the fours. So it is subtly different. What's Harry Potter's favorite mode of transportation? Walking. JK. Rolling. Oh, that's cringeworthy. That bad joke. That's a good one. Alright, then we'll have the value as a U8 there. Good. Shore noise value. Shore lands X has F64. Alright, there was one other thing up here. This should be called shore. And this one doesn't need lands, that's right. Alright, now when we have the triangle heights, see, is there anything else we need to do with this? I mean, maybe extract this stuff out to like a constant, this 3, this magic number here. Probably that. What else? Oh, it's a float. Okay, let's fix that. All right, now for set triangle heights, we should be checking to see whether or not the center of the triangle, well, okay, is within the radius, or if it's radius plus shore. Oh, I see. So we have the maximum radius, which is just the size divided by 2. And then we have shore radius units. Shore radius, it's not really like the shore, I don't know, length shore size. It's got to be a better name for that because it's not the radius. We'll just call it size. So if the distance to the center of the triangle is inside the shore, use island noise. Otherwise, use shore noise. So we're going to be calculating the height here, and that's all that is. So for every single triangle, using our combinators here, it's not really an intermediate. This is more of a for each, isn't it? There, that'll drive it. How do you calculate the center of a triangle? I don't remember. I mean, you can do it with the half angles, right? Center of gravity of a triangle, which will be fine. Just the average of the vertices. Oh, thank you. When you say it like that, it sounds so simple. Oh my goodness. Okay, so we have the triangle. So we'll take the center, and then we will check to see if that point is within the island. Are there any edge cases, like negative values, stuff like that? Let's think through that. No, we'll try. We'll try. So we'll have the triangles. We need a couple more things. This is what it feels like to not I know, like you will never use this in your working career until you do. That's right. We need the island size. We also need the lands with the triangles and the noise. All right, we need to create a center function on there. Oh, just create the function for me. That's our impl. Oh, did we not have an impl for triangle? Generate an impl for triangle. There. Oh, function center. Takes a self, returns some point. Does iterator have any like cool functions like average or anything? Probably not, does it? Like, I thought they had like some. So they do have some. That's cool. It's just a fold. Yeah. Yeah, but I don't really have anything to iterate over. Anyhow, x is going to be a0 plus b0 plus c0 divided by 3. Y and those are 1s. Then we return x and y. Yeah, it's... Oh, I need self on these, don't I? Oh, you know what? Let's do a destructuring. That looks so much prettier. This looks correct to me. Let's see, ABC. Oh, we add up the x's. We're to F64 divided by 3. Same with the y's. Those are all 1s. Good. A, B, C, 1, 1, 1. X and Y returned. Alright, now we have our center, and we can look it up in the noise. Well, we need to get the distance to some other point. Can we implement functions for other things? My thought is, can we do stuff like this? That's what traits. Oh, of course, that's what traits do. So if I have a local trait that's distance 2, just call it distance. Do we want that to be an associated trait type, though? Oh, yep. Other is going to be basically the same type. Those don't need to be public. Huh. Hey, good morning, Museum. How's it going? Two extra. 4, there we go. So if we have this, and the other one is also the same thing, I think that, yeah, okay. The long scenic numbers of 66. It's like Route 66, right? Self 0. These are already F64, so we don't need to do that. Oh, this is cool. We could actually do... Let's switch this up. Let's see, the only reason we're using the 2-element arrays instead of tuples is because the this other type supported it. I didn't feel like creating another type. Other point here is it has position 2D. Because you have the berry center, you have the geometric center, right? The center of all the angles. So I don't know if those are the same. Yeah, see, they implemented this on arrays and not on tuples. Why would they make that decision to implement this on an array like this instead of a tuple? Instead of using .x1, they're using square bracket 0, like average center, orthocenter, vertices cross. Okay. Ah, okay. Oh, that's cool. Centroid being the most common. Let's see. All right, so then we have the center. We want to get the distance. So this is going to be island size divided by 2. Benefit of them being square. Okay, so we have that. And so the distance to the island center, if it's greater than some magic number, then we use one value, one noise, otherwise the other. So in this case, we will take it, if it's greater than foobar, we'll then say then it's a shore value. Shore noise value. That needs to be borrowed. And did that just want X and Y? Yep. Pupils are rather limited, I see. Once Constraints lands soon. Oh, I see a lot of that spade crate can be constified, which will let them implement everything for both F64. Oh, wow. Yeah, I was going to wrap it. I just never got to it. Because it could be a point, yeah. All right, and this is going to be the height. there's that. So we set the triangle height. Oh, found a U8. I32 found U8, yes. Alright, now this foobar value. That's right, we added two more. We added the size and the lands. And the size is what? There's noise. Here's island grid. Oh, it's here. It's that 9 value. Downsize to tuples. They are laid out like structs, so the compiler can reorder the field. Oh, however, C is and adds padding. Wow. Alright, we call it island lands. Borrow those. Drink some water. Alright. So we're just going to run this test again. I see, their exact order is unspecified because of that. And that's the same with tuple structs, etc. Oh, look at that. This island has a height of 1, and I'm glad these other ones got removed. So the only one that actually survived was this one, which is fine. Let's run that again. That appears to be the right coordinates. 4, 5? Yeah. Are they clockwise? One, 2, 3, 4, 5. Oh, 0 based. So it's starting with this bottom right. Then it goes to 3, 5. Yeah. I went here and then 3, 4. Okay, that's clockwise. That'll work. A tuple, tuple struct, tuple variant and structs are all the same. Oh wow, they're all structs. Huh. What's the drop order of a tuple? I mean, now that you've said that the order is stored unspecified, I'll have to think about that. You're talking about the, hmm.
Bad devil's gonna rend your skin now. Won't pull you down to the
Oh, that's a good question. I don't know.
gonna cleanse your sin now. Safe from
This feels like it's in, it's actually in the, Ditolne's, quiz. Right? I think I saw this in the quiz.
free faith or by the force of my hand. You're bringing me a soul to save.
All right, let's run this again.
From my great divine land.
Okay, here we have two triangles. That looks good, and they both have a height of 1. I don't think we're gonna get a height of 2. Actually, that one was interesting. Why does that one have a height of 0?
Step off the guilty path and come into this world of mine. The earth is collapsing down.
Oh, that's a bummer.
Off the guilty path and come into this world of mine.
I mean, I expect certain elements to have heights of 0. Especially on larger islands, there will be triangles or pieces in the center. This one doesn't have any triangles? Oh, that's an interesting test. Alright, we need to print out the noise, basically the params for this. Is that's a valid... is it... Is it because it doesn't have a border on the right side? What about the memory freeing order? Drop doesn't free memory. Oh, right, it runs before the glue runs, yep. So we're gonna have Island Seed, Island Mask. Okay. This one also should have a valid triangles. It's gonna have these points. Go here. Oh, that's an interesting set. Okay, why is that one failing? Because it should end up calling this one, come back to this, come here. I think it can walk the neighbors in this whole thing. That's an interesting one. Let's try that again. We don't need that many on the right. Let's trim it down a bit. And comments to keep its shape. All right. Yeah, this one should have resulted in no polygons. This one up here should have resulted in polygons. Actually, these are very, very similar with the exception of, say, the center being a 0 or not. Because the way this should work, it should come through and record basically every transition that we have here. Say 2 sets of transitions, but it'll exclude all the zeros because it knows that we're not dealing with water. Let's see what it gets back from this. Oh. Failed island test 1. We're expecting only 1 set of lands, that's fine. Alright, island zone points. Just to see, make sure it's not that. All right, how many are there? 1, 2, 3, 4, 5, 6, 7. 7 zone points. That look correct. 1, 2, 3, 4, 5, 6, 7. Yes, that's correct. Now the pulleys. All right, so it's got to be in here somewhere. Bum, bum, bum.
Under a silver sky, I wander. These broken highways have become my home.
So we push the starting point on there, and as we loop through, let's look at the shape. And we look for a neighbor. Oh, here. Nice. It's funny because I did the loop first and ended up adding this later. I didn't see that. Thank you, Museum.
Shattered remains of once great cities. These silent highways lead to halls of stone. Every horizon sees it closer now. I'll venture onwards into the unknown.
Because what's supposed to be happening there is it's supposed to get the first point and then walk it clockwise around. So as we come through here, our shape is first points 1, 4. So the first point is at 1, 4. Then it finds a neighbor here, adds the neighbor. Neighbor's at 2, 3. Great. Finds another neighbor, index 1, adds a third one. This is good. Alright, finds another neighbor, adds a fourth one. Finds another neighbor, adds a fifth one. Neighbor, 6. Neighbor again, 1, 2, 1, 2, 3, 4, 5, 6, 7. Now we got a none. I believe this is the part where it has a little dingleberry off in the bottom left. So it's going to pop one off. Should be down to 6 now. It's down to 6. Oh, it found none again. I don't think that should have been the case though, because it should have been able to go up 1. So the last point here is at 2, 4. Zero, 1, 2, 1, 2, 2, 4. It should be able to come up here and find this one, but it's not. That should be direction 0. It's north, isn't it? Yeah, let's do that too. Where's point? It's in a different crate here. All right. If I want it to look like a tuple. Oh, neat. Yeah, let's do that. So f dot. I see. We can also do list mapper set. Oh, that's cool. Just to try that again. They are. That was cool though. That was neat. Yeah, and then we just keep going none, none, none until it gets reduced to nothing. Okay, now, out of curiosity, the first point is at 1, 4. 1, 4, 2, 3. Where's a 7? 1, 2, 3, 4, 5, 6. Here's a 7. Come on. So 1, 4 is a... Oh, this is the wrong space. Oh, no, 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 that is. Oh, I was looking at the wrong block earlier. It actually starts here? Oh. Well, that's odd. Okay. Well, that's a problem. Yeah, that does help quite a bit. Scrolling. Because if it had started up here, I could understand it, but because it starts here, there's no way back to it. So a starting point always has to have 2 neighbors, doesn't it? All right. Interesting. All right. So this starting point, we need a little bit more criteria than just trusting that it has whatever it wants. Ooh, okay, so I also find it strange that it's using the very bottom left element, because that might be the last one that got pushed on there. Probably is. All right. So the starting point must have more than one if it doesn't have more than one. So let's count the neighbors for the starting point. It'll give us an iterator of the neighbors, and we will bold on that. Neighbor count and direction. We'll figure that out in a moment. Okay, so here we have the neighbors we're going to be going through. We just want to see if there is one. And this is any, so we can short circuit. So if any of those, then neighbor count plus equals 1. Let's see, does Rust have ternary? It doesn't have ternary, does it? Oh, swap, remove, reord is it? It should have been the first one. I wonder, we must be doing that somewhere else too. Alright, so in this case we have otherwise just neighbor count. And then if we have more than one neighbor, we'll continue, otherwise we won't. Yeah, I don't think we really care about the order of this one at the moment. Okay, so hopefully this will pop that first one off when it discovers that it doesn't have starting point. All right, so 4, 2. Keep adding them around. Okay, we're up to 5 there. 6. Come back 1. And then we're done here. Then we have our polygon. So this polygon has 5 points in it. Interesting. Which ones did it not have? Oh, that's not the right one. We're not going to draw that right now. We're just going to go back to the code. So I had 4, 2. So I started with this one after that. 4, 2, 4, 1. 3, 1. Why did it go backwards? It shouldn't go here to here. If it starts at 4, 2, it should come to this one next. And there's some other problem then. Yeah, it's going the wrong way around this. Oh, no, it's not, is it? Because it looks first up. Yeah, I had built this assuming that it would find the topmost row first and then basically crawl around to the right. But if it's not finding the top row first, that can be an issue. Hey, good morning. Happy Tuesday, our cooled. All right. I think the best thing to do in this case is probably to sort that vector. Or figure out why it got resorted. Scan. Left to right, top to bottom. Oh, I see. We're inserting it into a set because we do end up with duplicates. And then we drain them here. What am I making? We are working on the procedural island generation for a game we call Legacy. All right. See, I thought it was going to be sorted there. Oops. This here, sort. Obviously, it didn't sort it the way I wanted it. So what do we have inside of there? We just have point. Or too long. Is there already something to see, or only server programming at the moment? We're actually working on island generation for the client. Is this Vim? It is NeoVim, yes. So soon there will be more stuff to see on the client, but I'm not popping into that at the moment. Trying to figure this problem out here. So at this point we have sort. We've got some points. Sort them. Maybe the sorting is... Yeah, we can do sort unstable. That's fine. And we could give it a comparison function. How do you think it's going to sort the points here? They're just numbers. Yeah, Rust is working with Godot. I think the general advice is to use like GDScript and use Rust when you want something to be performant. So that's the way TM. But I didn't want to use GDScript, so I'm using Rust. Yeah, I think I want that reversed. So we could, here, let's just see. We'll reverse fix this. I don't really want, I'd rather just sort it once. I think that's going to fix it, but... You're thinking of writing programs in Rust for the Raspberry Pi. Oh, that's cool. Which Pi are you targeting? Oh, the Raspberry Pi Zero. Oh, that's cool. I just want to look through this, see what it's doing. So it starts on 4.2, goes to 4.1. Okay, that seems like it's climbing the right side, isn't it? 4.2 is this one here. No. 4.2 and it goes to 4.1 again. Okay, let's go fix that. How do we want these elements sorted? Nope, not in the right spot. Over here. That's better. And in this case, A and B are both points. So let's do top to bottom, left, right. So everything in the first row is going to be first. So if A dot, see, that's a point, isn't it? A dot Y is less than B dot Y.
you stare. I would watch you stare. Oh,
Where is ordering?
there. We
Standard comp ordering. Okay.
figure this out. Put your feet down.
Less, equal, or greater?
Swallow your choice instead. Terrified of what's left remains unsaid until you break my mind. Until you break
Oh, is this where you can just use beta y to comp B? Oh, does that return ordering? Oh, that would be great. Thank you, Darkwater. Is vec a macro for defining a vector? Oh, yeah. Thank you. And morning, Jemmett. How are you? Now let's do a match on this. There, that's going to be better. Because we have to handle the case where they're equal and then go to the X. Missing match arm. Fill it out for me, please. Thank you. So if it is less or greater, we're going to do that. Let's name it order. All right. So if they're equal, then we have to do the same thing for X. There we go. X to or then Y? Oh, no way. Whoa, 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 whoa. Really? Wow. Oh, that is beautiful. Wow. Now this ordering here, the then with, yeah, then with. And what does then with want? If and once, ordering. Okay, just a function that returns ordering. That is fantastic. All right, let's run that test again. Sorry, just absorbing the ordering bits. That is cool. It's really, really cool. And now we have 3-1, goes to 4-1, to 4-2, to 3-3. If we look at the progress it did, it starts at 3-1, goes to 4-1, so it's starting across the top, goes to 4-2, going down the right side there to 3-3, comes in 1 and down. You know, I think we should probably start the iteration kind of in the same direction or to the left of the direction that we were going. Because it's coming across, it's actually going to short circuit and go up. And then it's going to look at the remaining bits. Because I don't think it even evaluated that other value. Was it, this is 1.5? Did it even look at that? No. And then it just decided that it didn't have enough points when it was beginning, continued out of it. So I think this one's working, but I think it also helped reveal another odd test case. Yeah, the drain to collect. It's coming out of a hash map? Where was that? Here. I didn't see sort on an iterator. Is there a better way to do that? Yeah, it's a hash map. Oh, it's a hash set, technically. We're using the hash set to be able to deduplicate the points that are being found again during the other scan. Collected to a B tree map. Okay. So we're still inserting. Oh, interesting. Nice. A B tree set. Do you have an ordered set? I see. Said take, huh? Removes and returns the value on the set. Oh, this is nice. Oh, that's the value. Standard mem take on the vector. Standard mem take. Are we able to get the values out of the B tree set? Oh, you thought that's what I was using. Okay, gotcha. Okay, we'll import that. So the interface looks to be the same. We might want to implement ord though on point. Is it ord or partial ord? Or T is ord. Okay. Let's go to point. I could just swap them, but I would like it to be a little bit more explicit than just that. In case I come back, in 6 months from now and see, you know what, I could put a comment on there, but if I saw them out of order, I would probably sort them because I do that all the time. Ah, we need the beach reset over here too. Alright, so now that we have those, we should be able to get rid of that comparison. Map this into something else. And what did beach reset have on it? Extend order structural sub. Oh, that's neat. But is there a way to just drain filter? Nightly only. How do you get the values from it? I know it's got iter. Basically, I want all of the points. Want all of the points out of it into a vector. So we do into iter. What are we doing here? Why? Vector, mutably iterating through it. This here is a mutably borrowed that zone. We're going to map that into something else, a vector of points. I see, it's not wanting to let us take the intuitor here. Oh, interesting. It'd be a very efficient partition it into two. Oh, that's nice. I see. This actually should be an into iter also. We want to take ownership of those elements that are inside of it. All right. Although, why not just a flat map? Because I need some way to actually keep the points for the different levels of the island separate from each other. So the first vector is for the level 1. The second vector is for level 2. The third vector is for level 3. All right, let's see if that still works. Three, 1. Yep. Okay, so it's going across the top. So we're going to come up with one more example here. Because we want to start at the top of the island and move clockwise around, we need to remember which direction we're moving in so that when we start to iterate around the points, here, I'll show you. This one's going to be a little bit more difficult to explain. Alright, so we were just right here. Yeah, we were on this one. So there's... I know, our assertions aren't quite right there. It's fine. Ah! I lost it. I've lost it. There. We're going to create fail test 2. Because there's one behavior that I'm noticing here. With this one, I think we need one more column of zeros. Alright. So what we're going to do is replace some of these with 1s. So we're going to go around the edge. We go up the side here. It's going to look like an infinity sign, right? And that, for whatever reason, this island has 2 puddles in it. Could be possible. But I think the current way that this is going to work is it's going to see, come across the top, then it'll come down the right side. But because the way it searches its neighbors, it'll come up this way. Not find any other neighbors for this because we removed these. Oh, you know what? This might work. And then it backtracks and it'll come back over here and then come up this side. Oh, actually that might work. All right, so finishing this one up here. I want to get a recording of the polygon and just keep that in the test. Expect it's going to be this. With a vector and points. Lands is one, that's fine. So we will only have one set of lands. And then we will use our vector comparison stuff to make sure they are the same. Servac equals. Let's remove the shape from this. Vector, vector, shape. That is so gross. All right. Cannot move out of that. Ah. Oh, no way. 1 up 46 lets you do food at 0 to 0 now. Is that for indexing into arrays or for like tuple types? Ooh. Yeah, that is much more gross. So it's for tuple types then? Yeah. Oh, no, what is it? Remove? All right. There we go. Unfortunately, our assert doesn't deal with borrows. Yeah, assert vector equals. All right, so that passed. Let's remove the debugging. All right, now for this one. All right, now we need expected. I'm gonna do test 2 and make sure that it's going around the outside of this donut. No, we ended up with 2 shapes. Really? Why are there 2 shapes? Alright, so where do we start out? We should be at 2, 1. Why are we at 2, 1? Why here? Why not 1, 1? Should be over here. It'd be much nicer. Does it ever get to 1, 1? Looking through this. 1, 3, 1, 4. Unless I'm counting these wrong, it doesn't look like it's even seeing 1, 1. Draw points. Size, this is what? I don't know, it's at least 10. Island zone points. Another little debug function, so we can actually see it. Ah. Okay. Oops. Control Z. Nope. Control Z. There we go. Oh, shoot. Alright, so it's finding points. Expected slice of points. What is this one? Vector of points. Let's see what it's doing. Ah, well, that's not right. Oh, I see. I see. We need to have this correct. So the islet size is 1, 2, 3, 4, 5, 6, 7 across. All right, there we go. Now for looking at the unit test. It is still gross. I mean, no wonder. That does not look correct. Did I get that wrong? Should it be 8? 0, 1, 2. I mean, it's 7 wide. 1, 2, 3, 4, 5. Well, technically 6 tall. Make it square. There. Now it's a taller thing. That's so strange. Okay, there we go. We got it right. So it is saying this correctly. I love the little... That's so much easier to debug than actually looking at these values down here. How long have I been working in Godot? Off and on, year and a half maybe? Made little, toy projects with it and stuff. All right, and are these correct? 1, 2, 3. Interesting. The shape is now represented better. So you can see that it went across the top, across to there. Down the right side on the 5s, 5, 5, 5, 5. Then on that level, it's came across the bottom, 4, 3, 2, 1, and then back up the side. Nice. Ooh, we should make the shapes debug to the ASCII. The problem is it needs to know what the island size is. And the shape doesn't know what the island size is. That would be a great thing for the ASCII though. I guess I could scan through and see what the dimensions are, the max size. Yeah, then +1. Yeah. Well, this one looks like it's actually doing the right thing, which I was not expecting it to do. I think it's because it came back here. trying to find a failure case here. I think if we do this, that one will fail because it'll be able to come back up this row here and then connect to the origin point, and these points would not get used on the far left. Everything below that one, which is incorrect, and this is because of how it's tracing. Whenever it looks, it's not remembering that, hey, I'm going left, I should start south when I'm going left. Yeah, I think the rotation on basically the compass direction iterator needs to be a little bit more aware of the direction that we're heading in first. Okay, let's try that one again. I think this time it should fail. All right, representation looks good. All right. And at this point, come across the top, 1, 1, 1, 1. We come down the right side with all the 4s. Come back on row 5 with the 4, 3, 2. And in the X column, yeah, we actually come back up in column 2, but then we go back down to 3 and then 4. So yeah, this is not correct. All right. I'm going to call it for today. I didn't have coffee yet. I'm going to go have some coffee and some breakfast. And then next time I think we'll get that that fixed up. And to just illustrate what I'm imagining here, what's going on is, let's grab another one of these here. Copy. No, don't move it. Paste it. There. So we've got our bucket of stuff here. Okay. What ends up happening in these cases is, or what I would like it to do, is to search, in this direction, kind of go clockwise around it, and it's going to go clockwise in this direction, and then it's going to come across this way, right? Now, when we go to search, this first square here, it'll first check this square, then this square. It'll kind of go northeast, southwest around it, right? It'll kind of a clockwise search. Now, when it gets over here, this one also does this clockwise search. Okay, so that clockwise search just works the same way no matter what. As soon as we get down here, we first look to the previous space, which was removed. It won't find anything, and it'll search around until it actually finds this one here. Which is great until we get over here. As soon as we get to this square here, it looks north and it finds something there. Okay. Instead, if we didn't always start at 12 o'clock in that search pattern, in that clockwise search pattern, but if we started in the direction that we came from, right, if we started here and then came around, because we're always crawling around these shapes in a clockwise pattern, we want to crawl on the outside edge. And really we wouldn't have to start in the previous space because that one was already searched, right, by the previous square. And in order to find this square here, this square and this square were already searched. Okay, so we would have to start searching in this square and then move around. So we're going to pick up there next time, changing that sort of iteration logic to be aware of the direction that we're heading in as we do these sort of scan for the perimeter on this. Okay. What do we got going today? Is it a light week due to the holidays? I'm going to be streaming all week. Why can't I click on browse? There it is. Browse, science and tech. Let me know if y'all have suggestions on. And we'll filter it a little bit. Sometimes people don't get their tags right, so I don't search much more than that, or filter more than that. I'm going to be looking for rust here. We're going to scroll down to the very bottom. Oh, it is a short list. Moving beyond Hello World. Microsoft developer.
Forbidden fields and empty meadows, I wind and wander
Alright, we're going to raid in that direction.
to pierce the seal and loose the shadow that pulls me unto places that should not be disturbed. All that I will pass to
Alright, y'all. Well, thanks for hanging out today. And I think we've made some really great progress on the island generation stuff. There's just so many little nuances that we have to take care of. So we'll chip away at it a little more next time. Until then, bye-bye.